Today's lesson is lesson 16.2, Sequences of Transformations. A sequence of transformations is a series of transformations performed on a single figure. An example would be taking a triangle, rotating it, then dilating it, and then reflecting it. So it's different transformations happening to the same original pre-image. Today we're going to take coordinate notation. We're going to determine what our coordinate notation is from the problem that we're given. We're going to write that down. We're going to use the coordinate notation to determine our new ordered pairs, and we're going to graph and label our final image at the end of all the transformations. So in the first problem that we have here, the example, and I just want you to watch me walk through this example, quadrilateral MNOP will be reflected over the x-axis and dilated by a scale factor of 2. Write the coordinate notation, calculate the ordered pairs to complete the table, and graph and label the final image. Now the table for this one is actually already filled in. So let's talk about how these numbers came into existence. This first column is simply MNOP. These are the ordered pairs that are the locations for these points on this graph. So in our coordinate notation, it's just XY. The first transformation that's going to happen is that we're going to reflect over the x-axis. When XY reflects over the x-axis, X stays the same and Y changes signs. So we'll take our original ordered pairs, we'll keep the X coordinate, and the Y coordinate will change its sign. So point M was 1, 3. The reflection would be 1, negative 3. N was 3, 2. It will become 3, negative 2. O was 2, negative 2. It will become 2, 2. Remember, this does not mean that Y becomes negative. This means that Y changes its sign. So if it was a positive sign to begin with, it will become a negative sign. If it was a negative Y to begin with, it will become a positive Y. And P was negative 1, 0. It'll stay at negative 1, 0. So that's our first transformation. The second transformation was to dilate by a scale factor of 2. In coordinate notation, that looks like 2x comma y, 2y. So point M prime, which will be the point that we graph because it's our final transformation, we're going to multiply this middle column by 2. So 1 times 2 is 2, negative 3 times 2 is negative 6. 3, negative 2 will become 6, negative 4. 2, negative 2 will become 4, comma 4, and negative 1, 0 will become negative 2, 0. This final column is our image. This is what we'll graph. This will be our final transformation. So M prime moves to 2, negative 6. And make sure that you label these as you go so that you don't forget which point was where. N prime is at 6, negative 4. 1, 2, 3, 4. O prime is at 4, positive 4. And P prime is at negative 2, 0. And then use a straight edge of some sort, a ruler or a piece of paper, to connect your points. So M connects to N connects to O, O connects to P, and P connects back to M. So the first thing you'll actually probably notice in the new image is that it dilated. You'll see that it got bigger than the original image. And then look at how the points changed location because they reflected over the x-axis. M and N were originally in quadrant 1. When they reflected over the x-axis, they went from here to here. They went from the top to the bottom. They went from quadrant 1 to quadrant 4. So that's what we're going to do today. We're just going to do our coordinate notation, get our new ordered pairs, and graph that final image. So you need to grab your paper and a pencil, and let's do this second one. It says triangle XYZ will dilate by a scale factor of 1/2 and then rotate 180 degrees. So in our coordinate notation, we're going to start with a scale factor because that's what's listed first. And it's going to dilate by a scale factor of 1/2. So we're going to say 1/2 times X, 1/2 times Y. And then we're going to do the rest of our coordination for the rotation of 180 degrees. And when a figure rotates 180 degrees, the X changes signs and the Y changes signs. So we'll use our original ordered pairs and we'll work our way across the table. -4, 2 is going to change because we're going to multiply by 1/2. 1/2 times -4 is -2. 2 times 1/2 is 1. In point Y, 6 times 1/2 is 3, and 0 times 1/2 is still 0. At point Z, -2 times 1/2 is -1, -4 times 1/2 is -2. So our scale factor here is going to show us how our scale factor causes our triangle to shrink, because this is a reduction. And the thing that we're going to do last is we're going to do that rotation of 180 degrees. So this triangle is going to get smaller, and then it's going to rotate 180 degrees from where it's at right now. So while Y is here right now, when we get done, Y should be over here somewhere, 180 degrees from where it started. So the new ordered pair for our final image, Y is going to change, or X will change from a -2 to a +2, and the Y will go from a positive to a negative. In Y prime, the X will become a -3 because it's changing signs, and 0 just stays 0 because it's neither positive or negative. And Z prime is going to become +1, +2 because it's a change of signs. And then we're going to graph this final image. So X prime is at 2, -1. Y prime is at -3, 0. And Z prime is at 1, +2. And then we're going to connect those dots. Notice we did a reduction, so our triangle got smaller. It got half the size it was to begin with. And then because it rotated 180 degrees, it did exactly what we predicted it would do. Y moved from being on the positive side of the x-axis to being on the negative side of the x-axis. So that's the rotation. It dilated down by 1/2. It rotated 180 degrees. Pause the video for just a moment and work the last problem. When you've got that problem worked, come back and check and make sure that you have the same problem or the same answer that I have, that your transformations look the same as mine. So in this final problem, we're going to take triangle JKL, we're going to reflect it over the x-axis, and we're going to dilate it by a scale factor of 2. So let's do our coordinate notation first. Reflection over the x-axis is pretty simple. X stays the same, Y changes its sign. And then for my dilation, it's a scale factor of 2. So we're going to multiply X by 2, we're going to multiply Y by 2. So J is our first point at 2, 4. When it reflects, it's going to become 2, -4. 1, 1 will become 1, -1. And 4, 0 will stay 4, 0. It's going to because 0 does not have a positive or a negative status. For our final transformation, we're going to dilate by a scale factor of 2. So we're going to take this new ordered pair and we're going to multiply by 2. 2 times 2 is 4. -4 times 2 is -8. 1 times 2 is 2. -1 times 2 is -2. And then our final one is 8 and 0. And then we're going to graph those points because we want to graph and label the final image. So J prime is now at 4, -8. 1, 2, 3, 4, 5, 6, 7, 8. Make sure you label it as J prime because we don't want to get our image and our pre-image mixed up. K prime is at 2, -2. And L prime is at 8, 0. So because our scale factor was a number larger than 1, our triangle should have grown. There should have been an enlargement that took place. And then it's going to reflect over the x-axis. So while J was originally at the top of the graph, J is now at the bottom of the graph because the whole triangle reflected or flipped over the x-axis. So our pre-image was here. It reflected and grew by a scale factor of 2, and our final image, JKL prime, is where we want to end up.